In this lesson, we're going to look at some quadratic word problems. For the warm-up, it says, determine the maximum value of the given quadratic function. So we have y equals negative 2x squared plus 12x plus 7, and we're going to try to find the maximum value. So when you look at the word maximum value, what that usually indicates to me is that I'm trying to find the y-coordinate of the vertex of the quadratic function. Now, if the equation of the function was in vertex form, then it'd be very straightforward to figure out what the maximum value would be. But in this case, because it's not, I need to rewrite this in vertex form. So, there's a couple of different ways you can do this. You can either complete the square or use a shortcut, and I'll show you both ways. In terms of the completing the square method, you want to focus on the first two terms. And you want to factor out any coefficient that's in front of the x squared term. And then take the middle term divided by 2 and square it, and you want to add and subtract that in the brackets. So 6 divided by 2 is 3, squared is 9. So I'm going to add 9 and subtract 9 to balance out the equation of the function. And then I'm going to take out the minus 9 because I want the whatever's left inside the brackets to be a perfect square trinomial. So I get x squared minus 6x plus 9 minus 9. And remember, anytime you pull out a value from the brackets, you need to multiply it by the coefficient that's at the front. And you get y equals negative 2 x minus 3 squared once you factor out the perfect square trinomial. And then plus 16 plus 7 is, plus 18 plus 7 is plus 25. Okay, so the maximum value in this case is 25. And I'll show you how to do this using the shortcut as well. In the shortcut, what you could do is find the x-coordinate of the vertex by using the formula x equals negative b over 2a. And because the equation is in standard form, I'm going to look at the b value and the a value and substitute it into this little formula. And so I have negative 12 divided by 2 times negative 2. And so that gives me x equals negative 12 over negative 4, which is equal to 3. And so you can see here that that's the x-coordinate of the vertex once you had the equation in vertex form as well. Now to find the y-coordinate, which is what the value that's actually going to represent our maximum value, all you need to do is substitute in this value of x into the original equation of the function. And what I get here is negative 2 times 9 plus 36 plus 7. And so that's negative 18 plus 36, which is 18 plus 7, which is 25. So there's the y-coordinate of the vertex. And so what this actually represents is my maximum value. And I know it's going to be a maximum because the coefficient of the x squared term was negative, so that means the parabola is going to open down. So even if you use a shortcut to determine the x and the y coordinate of the vertex, you can always rewrite this in vertex form by using the a value of the original problem and then using the x and the y coordinates of the vertex that you just solved for. Okay, so again, the maximum value is still 25. Now, some word problems will need you to find an equation for the function in vertex form, and some questions will ask you to solve an equation. Differentiating between when you need each type of equation or function is very important. So, just a few reminders for you. So, if you are looking at quadratic functions, a quadratic function can be written in the form y equals ax squared plus bx plus c, where a, b, and c are constants, so they just represent a number, and a cannot be equal to 0. And if you think about what happens if a is equal to 0, what ends up happening is a times x squared would give you 0 times x squared, and so what you'd be left with is bx plus c, which actually represents a linear relation and not a quadratic one. So that's the reason why the restriction of a not equal to 0 is there. Quadratic functions are used when you are determining the maximum or minimum value of the dependent variable. So some examples of that is if you're looking for a maximum height or profit or a minimum cost, those kinds of things are what you need a function for. Okay? Remember that a function is y equals. Okay? it shows a dependence between x and y values, where each x value has a unique y value. So in a function, you have both x and y variables that exist. On the other hand, when you're looking at quadratic equations, a quadratic equation can be written in the form ax squared plus bx plus c equals 0. So instead of it equaling to y, you have it equal to 0. A, b, and c still represent constants, and a still can't equal 0. And to solve a quadratic equation, what that means is to find the x-intercepts or zeros of the corresponding function or the roots of the equation. So in this case, you'll notice that the only variable that you have here that you can solve for is x. So quadratic equations are used when you need to solve for x. Okay, so for example, if you're solving for a missing dimension, then you would need to create a quadratic equation and then solve for the variable, solve for x. Okay, whereas if you're asked for a maximum or minimum, you want to make a quadratic function, so you want to have more than one variable. You want to have an x variable and a y variable, so you can solve for the maximum or minimum or the vertex of the function. Okay, so they are different. So here's our first example. It says determine the minimum product of two numbers whose difference is 12, then state the two numbers. So I'm going to read that again. Determine the minimum product of two numbers whose difference is 12, and then state the two numbers. Now, I want to think to myself, do I need a quadratic function or do I need an equation? Well, what am I asked to find? I'm looking for a minimum product. And so the fact that I'm looking for a minimum indicates to me that I need to solve for a vertex. Okay, so that's some of the thought process that I would go through to try to figure out whether I need a quadratic function or equation. I'm looking for a minimum product. I know I need to find a vertex in order to find a minimum, which means I eventually need a quadratic function in vertex form. And if I need something in vertex form, I know that I need to create a quadratic function. Okay, the word minimum is what gave away to me that I need to create a quadratic function. And now this quadratic function is going to depend on a minimum product of two numbers. So I need to introduce some variables. So let P be the minimum product and let x and x minus 12 be the two numbers. Okay, so we're told that we have two numbers whose difference is 12. So difference means I'm subtracting, so I have x and x minus 12 as my two numbers. Now if I'm looking at a product, I know product is when you multiply terms together. So if I'm looking at the product of two numbers, I'm looking at x times x minus 12. And so if I expand and simplify the right hand side, I get x squared minus 12x. Now please remember to continue to write the p on the left hand side, just like you're writing the x and the x minus 12 on the right hand side, and you continue to simplify that side. You want to make sure that you don't skip out on writing the p on the left hand side, because oftentimes you forget about it and then all of a sudden some students make it equal to 0, which is kind of weird. I don't know why students do that, but it's probably because they're forgetting that there is already something on the left hand side. So don't forget to write the letter P on the left hand side. Okay, so from here what I'm going to do is I have the quadratic function. Now I need it in vertex form in order for me to figure out the vertex and then find the minimum product. So I want to write this in vertex form, and again you can either complete the square or use a shortcut. I'm going to use a shortcut. So I'm going to have x equals negative 12 over 2a, which is just 1 in this case. So I'm just using the shortcut. And so what I end up getting is x is equal to 12 divided by 2, which is 6. Okay, so what this actually represents is one of the two numbers that I needed. X equals 6 is one of the numbers. Now to find the minimum product, which is the first thing that the question asked for, all I'm going to do is substitute this back into the function that I created and solve for P. And so what I get is 36 minus 72, which means my minimum product is negative 36. Okay, so this value here tells me what my minimum product is. I can actually rewrite this function in vertex form to get p equals, coefficient here is just 1, so I have x minus 6 squared minus 36. So that's the exact same thing in vertex form. If you completed the square, you would have seen that as well. Okay, so what this tells me is that the minimum product is negative 36. We found out using the shortcut, and you can see that as well looking at the equation in vertex form. So that answers the first question. The second question then asks me to state the two numbers. Well, the two numbers I can write based on what the formulas are that I use to represent the two numbers. So my first number is x. My second number would be x minus 12. So I can actually solve for the second number by using the value of x that I have here. And so what I end up getting is x minus 12 equals, so if x is equal to 6, 6 minus 12 gives me negative 6. So my two numbers would be 6 and negative 6, and the minimum product would be negative 36. Now, you want to make sure that this makes sense, and it does make sense because if I multiply these two numbers together, 6 times negative 6 gives me negative 36. So that's just a quick way to check to make sure that your numbers make sense with your product. Okay? So, therefore, the minimum product is negative 36, and the two numbers are 6 and negative 6. Okay, so there's an example of a question where you're asked to find a minimum, which indicates to me that you need the vertex form of a quadratic.